So this is number 2 from your classwork. And with this example, we're going to do subtracting, and we're always also going to look at negatives. For this example, I'm going to show you 2 different ways that we can break this down. I have 10 to the negative 5th power and 10 to the negative 6th power. We're going to look at 2 ways to break it down to see if we can get to the same answer both ways. So first thing I'm going to look at is 10 to the negative 5th power. I know that negative 5 can be broken down into 10 to the negative 6, because I wanted to get something that matched that. And I can also multiply it times 10 to the negative 1st. 10 to the positive 1st, I'm sorry. Because negative 6 plus positive 1 is going to give me negative 5. So they are equivalent to this negative 5, but now I have a negative 6 so that these exponents are the same. So I'm going to group that 10 to the 1st power with that 8. I'm going to do 8.41 times 10 to the 1st power, and then I'm going to multiply all of that times 10 to the negative 6th power. First, I'm going to move this. I know that this is a positive 1. I'm going to move my decimal to the right once, and I get 84.1 times 10 to the negative 6th power. And then I'm going to leave that the same, and I'm subtracting 7.9 times 10 to the negative 6. I know these are going to remain the same, and these decimals need to be subtracted. I can't subtract 9 from 1, so I'm going to borrow from the 4. It becomes a 3. 11 minus 9 is going to be 2. Bring down my decimal. Can't subtract 7 from 3 and borrow from the 8. The 8 becomes a 7. 13 minus 7 is going to be 6. Then 7 minus nothing is going to be 0. 7 minus something is going to be 7. 76.2 times 10 to the negative 6th power is our answer. Now I'm going to try this again, but this time I'm going to look at how can I break down that negative 6. I'm just rewriting that expression. Now I know that negative 6, 10 to the negative 6th power is the same thing as 10 to the negative 5th power. Again, I'm trying to match this times 10 to the negative 1st power. And negative 5 plus negative 1 is going to give me that negative 6. And I'm going to rewrite this grouping, rewrite that 7.9, going 7.9 times 10 to the negative 1st power times 10 to the negative 5th power. And I know that to the negative 1st power, I'm going to move 1 place, but because it's a negative exponent, I'm going to move 1 place to the right instead of the left. So now I have 0.79. That's my fault. 0.79 times 10 to the negative 5th power. And I'm going to go ahead and subtract that again. So now I have 8.41 minus 0.79, and both of these are times 10 to the negative 5th power. And this is going to remain my power of 10. And let me just subtract this as usual. Can't subtract, I have to borrow from the 4. The 4 becomes a 3. 11 minus 9 is going to give me 2. 3, I have to borrow from the 8. The 8 becomes a 7. 13 minus 7 is going to give me 6. Bring down my decimal point. 7 minus nothing is going to give me 7. Now I have 7.62 times 10 to the negative 5th power. Now let's compare that to our answer that we had before, which is 7.62 times 10 to 76.2 times 10 to the negative 6th power. Are these two the same? The answer in this situation would be yes, because if I have 76.2 times 10 to the negative 6, I'm going to move my decimal 6 spaces. 1, 2, 3, 4, 5, 6. And then I have 1, 2, 3, 4 zeros in front. But if I have 7.62 times 10 to the negative 5. I'm going to move my decimal 5 spaces. 1, 2, 3, 4, 5, with 1, 2, 3, 4 zeros in front. The answer is still 762 tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 million. 762 10 millions for each of these. So they are the same answer, although they look different. Sorry, I didn't know that was out of the screen. So they are the same answer, although they look different. So be careful about those two. Remember, you can do it either way, whichever way makes more sense for you.